Now that we know exactly what these strange materials are and how they are made, what properties of these materials make them special? One of the most remarkable properties of aerogels is that they are the lightest solids in the world. The large number of holes in the solid nanostructure give aerogels tons of air pockets that make it almost entirely made of air, 99.8% air as a matter of fact. Because aerogels are almost entirely air, they also have very low density. The lightest aerogel is only 3 times denser than air, although they are typically around 15 times denser than air. For this reason, aerogels are often referred to as liquid smoke. Another remarkable property of aerogels, and perhaps the most important, is their ability as a thermal insulator. Heat can be transferred through multiple mechanisms. Conduction, heat transfer through a solid; convection, heat transfer through a liquid and gas; and radiation, heat transfer through electromagnetic waves. Lower density materials are not as good at conducting heat due to the fact that the molecules are not as packed close together, and thus cannot transfer heat between each molecule as efficiently. Because aerogels are almost entirely made of low-density air, heat does not pass through well due to conduction. If the solid material is also a bad conductor of heat, such as silica, this can make aerogels an even better thermal insulator. Additionally, because the pores are so small, air cannot flow easily through convection. Think about how you feel colder on windy days. This is an example of convection. Thus, aerogels essentially nullify 2 of the 3 methods that heat is transferred. Radiation, however, may still pass through the tiny pores of the aerogels. This thermal insulation is the best in the world. You could put a flame right below an aerogel with a flower on top, and the flower would remain untouched. Where aerogels excel in thermal insulation and lightness, they sacrifice in strength. Although inorganic aerogels can hold up to 2,000 times their weight, they are extremely light and thus can be broken by the same pressure it would take us to crush a piece of Captain Crunch cereal under our finger. Aerogels can be made stronger by increasing their density, at the cost of losing their light weight and great thermal insulation. Some aerogels, however, can be made remarkably strong and hold tens of thousands of times their weight. They are called X-aerogels and are made by linking together polymers, which we will describe in detail in a subsequent video. Despite some downfalls, aerogels still have some of the most unique properties in the world, and we have taken advantage of them to do things never done before.